shields, which we'll talk about a little bit later. Um, and yeah, we did all the whole Arduino libraries, the iOS libraries, and soon the Android libraries to make it as easy as possible to work with Bluetooth 4.0. Am I missing something on this slide?
Yeah, basically to abstract everything that you might have heard of, like profiles, UUIDs, discovery, writing data. All that is, you'll see later on that it's really, really easy when it comes to the BLEDuino. You don't have to like deal with UUIDs and none of that stuff. We built the profile. We built it in a way that it's really broad, so you can do a lot of things.
Yeah, and it's all open source, so if you do want to get into the nitty gritty, you can.
Nice.
So the hardware on the BLEDuino, it's the Mega 32U4, the same one the Leonardo and the Arduino Micro uses, with a modified Leonardo bootloader. It uses the 32U4, which has HID support, so it has built-in USB peripheral
and keyboard.
Yeah, you can do that. You can use keyboard, emulate keyboards and mice, and has all the features that a regular Arduino would have. All the GPIO pins except two, and all the analog pins, all the PNW pins. And actually, as you can see here, the top two chips that you can see here, the ICs, are the Nordic IC, which is the top one, and the bottom one is a secondary microcontroller that we use to handle all the Bluetooth stuff.
Yeah, we sort of confused the photos.
Yeah,
you'll see on the next slide.
Yeah, we mixed up photos. There we go. That's the main microcontroller. That's the 32U4.
32U4, right?
Yeah. Yeah, that's all the power supplies and all that. And so, yeah, we used we were gonna use a chip antenna, but decided on using actually a
trace antenna.
A trace antenna, because that was, although it was cheaper and actually ended up with a better range. So
yeah, you can barely see it, but you can see it here behind all the logos.
Yeah, good stuff. And so yeah, so we decided to use a dedicated controller for the Bluetooth part to use the least amount of pins on the 32U4, so you could have access to all the shields and pretty much treat it like an Arduino and not use up like 7 or 8 pins that the NRF 8001 would have needed to be used.
So basically, we use a dedicated controller specifically for the BLE chip, just to be able to like for the BLEDuino to be nearly compatible with all shields.
Right, and not just compatibility, but to really abstract it as much as we could. And if you want to get deep into Bluetooth, you could just get and modify the secondary microcontroller's code. Right. And there's all the abstraction for the Bluetooth section is there. So anything you want to do, that microcontroller. Anyway, yeah, the shield. One of the main reasons we used 2 microcontrollers was so you could use all the shields that you wanted with the BLEDuino. So a lot of people are really into shields. It makes prototyping really fast, and so if you want to just use one of the shields that you're just lying there around your house, you can just pop it in the shield, pop in a shield, and now you got access to that shield.
Essentially, shield, what it does is just extend the layout, convert the layout of the BLEDuino into a standard Arduino Leonardo pin layout, so you can use the shields.
Yeah, exactly. And since we're sacrificing 2 of the pins, we're using this switch right here to actually change the compatibility. Like if it's one of the new shields, you're probably going to want to have it on the left. If it's one of the old shields, you're going to put it on the right. So that's it makes sure you can actually use all the shields in the market right now.
Because the whole layout's changed a little bit between the Arduino Uno and the Arduino Leonardo.
Yeah.
So shields are being designed differently.
Yeah.
And we wanted to truly, genuinely support almost nearly 100% of them. And that's why we have that switch there, so you can swap out between the old layout and the new layout, sort of.
Let's see.
So what Angel mentioned earlier is that we build all these different libraries to sort of like abstract everything about Bluetooth and make it really, really simple for either anyone that just want to deal with Bluetooth in a simpler way, or anyone that doesn't want to deal with the software side with the software on the mobile side. So this is our app, and it has 8 models. We are adding extra models later on. We're still building those, and this is basically what will enable you to do all sort of different things without writing any kind of code on the mobile side. And if you use the sketches that we include with our library on the Arduino side, then you don't even have to do software on that side either. So one of the things that we're kind of like really proud of is our BLE profile, and that's because when it comes to BLE, it's supposed BLE the whole protocol is meant to be very specific for like end products. So if you're building something like a heart rate monitor, you should probably be using either the heart rate monitor profile that Bluetooth already built or something very similar to that. So that's very specific, right? It includes data like heart rate measurement and body sensor location. But when it comes to BLE, like a development board in general, then the goal is to be broad, right? So you can build as many different kinds of projects. So we had sort of like to strike a balance between being very specific, which we would come up with profiles and services that didn't really make a lot of sense, wouldn't be that useful, and the other side, which was like too generic, like one service that would do everything, then it would make it really hard for people to sort of like in understand that data. On the other side, they would have to like build a lot of software just to sort of like and understand that data. So we went with a balance between those two, and I'll go over the different services that we include right now. So the first one is just the really generic one, and it's just it's just to send raw data and strings. That's the one we use for the LCD module and the keyboard module, and that's why we use it for that, because we're essentially forwarding a message, and that's it. We're not interpreting that data. We're just forwarding that. But we don't want to do this just for everything because it doesn't really make that much sense. So we built extra services for that. So Firmata, it's essentially allows you to control and or alter any state of any pin on your BLEDuino board, and the kind of data we send is the pin number, the pin state, which is like is it PWM, output, input, analog, all of that, and then the value. And the value is to know whether is it high, low, or what kind of PWM value is.
Yeah, actually, there's a typo there. It's supposed to say Fermata.
Yeah.
But yeah, I'm sure most of you are familiar with that.
Yeah, last minute mistakes. Anyway, so this service is the one that powers our power relay module, which is the one that you see on the right side, which is just a simple interface to have an on-off button to anything that you want to plug into your BLEDuino, basically. And it also powers the LED models and eventually the extra model called Fermata, which essentially would give you access to every single pin just from the interface without having to touch any kind of code. Yeah. And then the vehicle motion, I'm a big fan of radio controlled cars and RC stuff in general. So I wanted to build something that would enable us to build stuff like that, and kind of like the same RC car that we have on the Kickstarter video. And but we wanted to do it in a way that if someone wanted to build a boat or an airplane, it would work as well. And there's so many controllers out there that control the motors on the like RC side that we were like, how do we do this? So we just went with sort of like pitch data. We're gonna use in our sketch to build our own, RC car. But if you want to do something else, you're definitely available to do anything that you want.
Yeah, you can just read those values and translate it into any vehicle that you want to use.
Right. For any controller that you want to use.
Yeah.
And then the controller, it's more like a game or video controller. It's sort of like emulate any kind of controller that you want. I don't know what's the limit. I think like 255 different buttons that you can have. Yeah. And the data we send is the identifier, which is just a number, so sort of like set up the layout of the controller. The status, which is like, is it pushed down or is it released? And then the value to handle joysticks, basically. So we can have flow data, which is like 90 degrees, minus the 90 degrees and all that. And this is what powers our game controller mode, which you'll see later on.
Yeah.
So here's the notification, and this was built essentially to make it really simple to receive notifications on the phone.
Yeah, push notifications.
Right. So we wanted this model on this service in general. The whole purpose is to make things like sensor data very, very simple. Like you only have to call one method, which is like start receiving notifications. Can't remember the exact name, but then you don't have to do anything else on the code, and you can see that in our library. And then we have a specific format that we're gonna have available in our documentation. You don't have to follow it if you don't want to, but that's how we send the payload to be able to like have already the interpretation software do that very quickly and easily. And then finally, we have the BLE bridge mode, which is the one that I like the most. It's essentially sort of like a workaround. Peripherals like the BLEDuino are not really, the protocol doesn't support for direct communication because that's not how it built. It's a master-slave relationship or central peripheral. Where,
Yeah, the BLEDuinos are always slave devices,
right.
and so this allows the phone to act as a bridge,
It's a gateway.
as a gateway, yeah, between the BLEDuinos. So if you want one to talk to another one, as long as you have a phone in the middle, you can just have them all communicate within each other
Right.
in a star network,
Well,
basically.
any BLE central, so you could sort of like take our code and put it in a Mac
Yeah.
computer or anything else BLE, and you can make your own bridge for that. And what we send is just the raw data and the identifier, but it's as simple as calling one method, which is called open bridge, and that'll take care of communicating with every single BLEDuino that is connected, asking its ID, and then whenever another BLEDuino is sending like, hey, I want to send this data to BLEDuino B or C or D or whatever, the phone will take care of everything, and you don't have to write any kind of code for that.
Yeah, it's very straightforward.
And so I just want to say that both the BLE bridge and the notification might seem a little bit redundant in the sense that they work a lot like the UART service, which is the one that I mentioned first. But the whole point to have this sort of like redundant services is to so you have specific channels for specific things. One of the main characteristics that we wanted to accomplish with the BLE bridge was to be able to send data in the background, so you can build stuff like have a BLEDuino that has a sensor that detects when you open your door when you come into your house, and then another BLEDuino that turn on the lights or do different things. That all that should happen in the background, and you should be able to also send that data in the foreground, so you can use both the UART channel and the BLE bridge channel at the same time, or the notification one, and then you don't have like to write this insanely complicated interpretation software because you have specific channels for specific scopes, basically. So what we did for the BLEDuino software in general, and this, the right side is the Arduino side and the left side is the mobile side, is that when it comes to iOS, what you would typically work with is what it's on the bottom, the core Bluetooth SDK. There you have to handle all the characteristics, which is basically the data that you send and all the UIDs and all that. We extracted all that in the services that I just mentioned that you will see later on. And then on top of that, we built our own application that it's powered by our own library. And the same thing is happening on the Arduino side. There is a Nordic Arduino library that takes care of talking to the Nordic NRF 8001. And then we extracted all of that in different functions and classes for the Arduino. And then we have sketches that sort of like take power of that library. And this is an example, and Legend Angel continue.
Right. Which example was this? All right. So this is how the sketches are going to work. So I tried to abstract as much as I could here without losing the ability to be specific on using the services. So how it's going to work is you initialize the BLE object, and then you begin a certain baud rate. This will probably change in the final one. We'll probably just remove this and just keep a fixed baud rate for stability. And then so you just attach a function to whenever you get data, an interrupt will get fired, and this function is the one that will get fired, which is a function that you will define. In this case, define here. So whenever the phone sends data to the BLEDuino, this function gets fired. It just reads the data, and then in the loop, it just does whatever it is you want with that data.
Yeah. Essentially, you're attaching a function to a service call, basically.
Yeah.
When you get, so you will have different ones available through the library. So you have for the different services, right? For the free meta, for everything, you'll be able to attach your own functions to deal with those as you want.
Right. And if there's nothing to do, you can just go to sleep, and it'll since it's interrupt based, it'll wake up when you get data.
Right. And this is just an example of how we do something similar on the iOS side. You basically, so this is for the Fermata service. You basically build the command first, which has a state, this case output on high, and then just a pin number. And once you build the command, you essentially just send it. You just write the command. Here I'm just getting the manager and saying, hey, tell me all the connected BLEDuinos, and to all of them, send this command. So it's as simple as that. Just build a command. If you want to talk to just one BLEDuino, you don't have to do the for loop, and it will be just like 6 or 7 lines of code to essentially send commands and receive commands as well if you want to. And then when it comes to handling the manager, it's just calling the manager, send delegate, and you're probably in your app delegate when your app starts, and then make sure that it starts scanning for BLE devices. And you can handle this as you want. We have two demos for you today. One, we do it manually with our app, and then the other one sort of like does it on the background, just then starts to scan and connects to the BLEDuino as soon as it finds it. So you're open to either however you want, but it's this piece of code that handles it. All right, let's go to the demo. Let's hope we don't crash and burn.
Let's do it.
All right.
It should be a fun one.
All right. So here's our BLEDuino, just in case you see it. Oh, and this camera sometimes is not very friendly.
Don't worry about it.
All right. Anyway, so this is my phone, and I'll go to the app right now. So already found it, connected to it. And this is our official app that it's already available in GitHub. All right.
I don't know if we can show how I'm playing actually.
Oh yeah.
Yeah. Wait, there we go. Ah, nice. Yeah.
Anyway, you get the idea of what you can do.
Yeah.
All right. All right. So what we want to do now is just show you what's happening on the background on both the iOS and Arduino side.
Yeah.
So this was our app, right? So here, like I mentioned in the app delegate, I set up my manager, and then we have on the discovery manager, which is the menu you saw where I scan and connect it. Here's where I handle all the part of just scanning and start scan for BLE devices and all that. But what I really want to show you is what's happening on the actual model code. So we have that view that you saw, which is the gain controller, and this is our controller, our iOS controller for that. And all that's happening really is that after setting everything up, this is our joystick right here, and this is creating the button action characteristic, one for the vertical and one for the horizontal joystick, and then it goes here and it just sends it after it gets builds the service and passes along the characteristics, which is basically the data that it's sending, and it just sends it, and that's it. The same thing happening for the 4 buttons. You have it here for just when you press it and when you release it. And the same thing happening here. You build it, you give it an ID, you tell it what's happening with the button, whether it's released or it's pushed down. Then for every single BLEDuino out there, just, hey, this service controller service just send this data to the BLEDuino, and it writes the button action. That's essentially what's happening. So it's not that complicated. And then Hopefully I can show you the Arduino side of that if I can find it. All right,
There we go.
all right.
Yeah, I'm gonna go over this really quickly. So, similar to the other generic code that I showed you, this one's a little bit more concrete. So, I'm initializing the BLEDuino object, and then I'm gonna use the keyboard, so I just initialize the keyboard too. I attach a function that's going to get fired whenever I receive data, which is the get controller data. All it does is that, go down here, the get controller data just saves the relevant values to it, to my global variables, and in my loop, all I do is when something interesting happens, when I get data, I do something with the controller. In this case, I want to translate those keys that I'm getting from the iPhone into actual keystrokes that I already know which ones I want. So in this case, when it's the joystick, I do this whole joystick function that handles that, and then the keyboard ones, I do a keyboard action, which is just it says if it's either pressed or not pressed, and it just releases or presses that key to play the game. So it's a little bit straightforward.
Yeah. Everything I want to say.
Yeah, that's just the logic to handle the keyboard presses, which is not really um, BLEDuino related. You know, it's more you get the keys and you make sure. Okay, so is it? Um, I get the state. Is it pressed? Is it not pressed? If it's pressed, then I use the keyboard.press. If it's not, then I use the release key to release it. So yeah, and this is kind of just in case. So.
Yeah, we have had many fun stories of not being able to use the computer because we.
Yeah, whenever you can do code that messes with your keyboard, you should probably have a fallback.
Yeah. So we want to do another demo, and this one's just to show you sort of like how easy it is to get started with the BLEDuino. Because I know that you saw the code for the app, but that has a lot of things. But I wanted to show you how simple it is. So I have a very simple project here. We're gonna build sort of like a light bulb with dimming, very simple with a couple of LEDs. So it's a simple application. It just has a slider, and it has basically nothing else. That's it. And we are gonna enable BLEDuino access to it right now. So first thing is that we gotta set up the manager to be able to access the BLEDuinos. Oh. Yeah. Meanwhile, Angel is updating the code on the BLEDuino. So we go to the app delegate, and this goes here. This is just setting it up, saying, hey, only scan for BLEDuinos, I don't want anything else. And then just start scanning. And by the way, I'm going to be your delegate, so whenever you find a BLEDuino, let me know. So that's what we're going to add right now. Just two delegates. This one, when it's discovering the BLEDuino, we're just going to go ahead and connect to it. That's it. And the other one's just letting me know when I actually get connected. Then one more thing to go, which is just to send the data. So here in our slider, right, this is a function that gets updated every single time that the slider gets updated. I'm just gonna put this code here. It's building the formatting command that is gonna control the LEDs. It's gonna set it to PWM, and the value is gonna come from the slider. And then we're using pin 3 to control everything. And then just finding the BLEDuino and sending the command to it. So that's set. I'm gonna say that I actually need to compile that into my phone right now.
Oh, do you?
Yeah.
Oh, okay. Yeah.
Do I?
We're doing it live. I like it.
Doing it live. Oh, let's see if this doesn't blow up.
Yeah. I don't think you need
But
that one, that camera. That's fine.
yeah, I wanna point this out. They see it. Just 1 second. I built it, so I need the USB right now.
Yeah,
But
Max should have more USB ports. Just saying.
anyway, let me set up the camera so you guys can see it. All right, there we go. All right, all right. So I built that. Let's see where it is. There you go.
Right. So it's just a simple dimmer.
Yep. So you saw it. It takes like maybe 20 minutes to build something like this with the BLEDuino, and this is essentially a light bulb that you can dim from your phone. Uh, you can make a lot better work than we did because it's a simple demo, but you get the message that it's just very simple, straightforward to build stuff like this on the BLEDuino. Can they actually see the lights? Yeah, they can see. All right, cool. All right.
Yeah, so adding control to things is relatively simple. It's just up to you to get as fancy as you want.
Yeah. So everything regarding the BLEDuino, it's completely open. All the BOM, the PCB files, AU files, all about the iOS app, everything about the firmware, everything is available already on the GitHub. There's some things that are missing. We keep updating it regularly. Our website is BLEDuino.cc. You can access everything there, and we urge you to go nuts, tinker away, build whatever you want. You can change everything that you want. If you don't want the profile, like uh, Angel was mentioning, you can go right into Micro B and just handle it yourself and change it and just update whatever you want, the app, the firmware, whatever you want. It's all available. And that's about it. We just want to thank you. Thank everyone for the amazing support that they have given us when it comes to BLEDuino and everything, especially our Kickstarter backers, which make BLEDuino a reality. And that's it. We'll open for questions now. I don't know if you want to take it away, Vincent.
Sure. Let me go find the questions. Somebody, you can type in your questions. For the attendees, you can type in your questions in the question panel so I can read it out loud.
Cool.
Sorry. First time using Go Meeting. I minimize the window. I can't seem to get it up again.
Okay. Here's the question. Can you have the BLEDuino connected to a phone and still be advertising its services?
Connected to a phone?
Yes. Well, you have a connection, and could the board still advertising its services?
Right. So, pretty sure that no. That's not because of the BLEDuino. It's just how the standard and how the protocol and how the Nordic BLE shape actually works. So once it establishes a connection, it'll stop advertising, and it'll just depend on that relationship that it has with that one connection.
Okay. Next question. The connection to your Mac, is it a USB connection?
Yeah,
Yeah, it's a USB.
it's a USB. That's how we were using the keyboard to play the Super Mario Bros.
Yeah, to be more specific, it's a micro USB connector. Yeah.
Very good.
The one that we doing it. Sorry.
Yep. Is there source files or source code for Android on GitHub?
Not yet. Not for Android. It's definitely on the pipeline. We started working on it, but it's not decent enough to release yet.
Yeah.
To be honest, and we're working at the same time on finishing the extra models that we promised as a stretch goal for the iOS side, and then working with manufacturing and all that. But Android is definitely coming, but it's not on the GitHub yet, unfortunately.
Okay. So if we miss the Kickstarter, how can we get a BLEDuino now?
You can't right now. We accepted pre-orders for about I don't know 2 months, 3 months after the Kickstarter.
Yeah.
But we closed it down for now.
Yeah, for logistics
Yeah.
to really nail down the manufacturing. Once we do the first run, which is very, very soon, we'll probably open the pre-order site again, but we'll keep everyone that's signed in up to date. So if you're interested, just go to bleedwino.cc
Yeah, and sign up.
and sign up.
Yeah.
We'll keep you up to date.
Very good. Next question. What methods do I have to control advertising and pairing settings?
What masters?
What methods in your SDK? Or let's
I'm
say,
sorry, I don't understand the question.
how can I control the advertising setting or the pairing setting?
Oh, okay. So, well, it depends on what you want, really. If you want to change sort of like the timing or the kind of services that it's advertising, then you need to go directly into the BLE ship, and the pins are available. They're accessible on the BLEDuino board. You have to sort of run some headers to it, but you can do that, and we can well, it'll be available in the documentation, but we'll give you all the information that you need to use that software that you have to use to update the profile and all that. It's for free, actually. So
Yeah, and besides, there are some basic commands that you can do without getting into the secondary microcontroller that you can do from just sending basic commands like turning on and off the Bluetooth LED and changing the name it's going to advertise and maybe changing the timing. But anything beyond that,
yeah,
you're going to have to get into the other microcontroller,
yeah.
start of the headers.
Anything beyond those like basic settings, it's already sort of like burned into the profile, and you can't change it just on the fly. You gotta update it basically.
Yeah, but you can just it's that profile and all that Bluetooth code is also written in Arduino, so you can just open up an Arduino sketch with that code that is also out and modify it. So it's really easy.
Okay.
As long as
Next
you don't
question.
write.
Yeah. How can I implement any of the 6 profiles or set up a get server? Say I have a new profile. I want to implement that profile in the BLEDuino board, the BLEDuino board.
So if you want to do a new profile?
Yes, we want to do a new profile.
Okay.
Okay. Then you sort of have to you can base yourself on hours, but you gotta the profile. It's essentially an XML file that it has just a bunch of settings and just words that basically it's sort of like a programming language, but sort of like to dictate the language that the BLEDuino, any BLE peripheral can speak, and the central device is going to understand. So it's sort of like if they don't speak the same language, the BLE protocol on that file sets the rules of the words and the sentences that they can speak to each other. So if you want to build your own profile, you would have to replace ours with yours and just go to use that Nordic tool that I was mentioning that's free and build your own and then burn it into the BLE ship.
Yeah, we're probably gonna have some instructions on how to, some basic instructions on how to do that in our wiki when we get all these documents done.
All right, very good. So have you guys tested with any of the sensors?
With any of the sensors?
Right.
What do you mean?
Say any sensors connect to the Arduino board. Have you tried that? Using the BLEDuino to transfer the sensor data to your phone.
Yeah. Oh yeah. You can see a bunch of examples in our Kickstarter page. We have one specifically that it was a light sensor.
Yeah, just a photoresistor that we used to sense light, and it would send a notification to the phone. And I guess we used other things, but yeah, you can just connect any sensor that you would connect to any Arduino. You can just connect it to this and send data to your phone. Yeah.
Yeah.
Okay.
As long as you you know follow the services, right? As long as you put the kind of data that it's asking for, you can send whatever, or you can use the generic one, which is UART, and then you can send whatever you want. You'll just have to add more software to interpret that data on
Yeah,
the other side.
you have to parse it on the phone side.
Yeah.
For yourself.
But you can pretty much send anything.
Yep. Next question: is it possible to refresh the board so it can advertise as a heart rate monitor, for example?
As a what monitor?
As a hardware monitor.
Heart rate monitor.
Yeah. You can reflash the chip that handles the Bluetooth, and you can do whatever you want with it. Yeah. So you can advertise whatever it is that you put in there.
Yeah, so the BLEDuino comes with our own profile that has a finite set of services, I think 6, that sort of like enable a lot of different things. But you're completely free and open to change whatever you want. And if you want to use a BLEDuino to build a prototype for an end product, and you want to build heart rate sensor, heart rate monitor, light bulb, whatever you want, you can come up with your own profile or use one of the ones available in Bluetooth. Granted that you would have to adapt it for Nordic because it's not direct. You have to adapt it for that specific chip. But you can put whatever profile you want and then just support whatever services that you want.
Yeah, but we did expose the pins to reflash both microcontrollers.
Yeah.
Okay, very good. Next question. This is from Ben. He's your Kickstarter supporter. And first, thank you for your project and your presentation. And his question is, could you explain what the characteristics are and how to declare them?
And how do they what?
How do you declare them?
Right. Sure. So the characteristics basically are the format of the data that you will be sending, and the services is a list of characteristics that like together provide that service, right? So I'll give you an example from art. So everything that you need. Oh wait, I forgot to mention that. I have already done it, but everything that you need to build what I did with the simple dimming LED example is just one folder that I literally imported from GitHub and just downloaded it and imported it into our project, and that has everything that you need to build everything else. But back to your question, I'll use the controller. So if you see here, all right. So this is our service, the controller service used for the game controller model. All it does is setting the peripheral, so you don't have to handle that, and setting the UIDs, so you don't have to deal with that either. And then when you go to write data, right? And when you have something that it's being powered by that service, and you go to write data, you pass that characteristic, right? What it's essentially doing, it's just taking care of that UID for you for both the service and the characteristic, and then just using a generic method that we wrote to send that data. So all you have to do at a high level to handle the characteristics is just to declare it and initialize it. So here we have a button action characteristic that only has an ID, status, and value. That's it, those 3 things. So here I'm using the status to say whether the button, because this is a button, whether it's a push down or released, and then just giving an ID to be able to tell on the other side what's happening, which button was actually I'm actually talking about. That's all you have to do, and it's sort of the same thing happening on the Arduino side when you want to send data from the BLEDuino to the phone. It's sort of the same thing. It's just not objects, but it's the same thing.
Yeah, it's kind of like an object where, the service would kind of be like the object, and the characteristics are the variables inside that object. So the characteristics are the actual tangible data that you're sending.
Right.
Okay. Next question. Can I build an iBeacon with BLEduino?
I was expecting that one. The answer is yes, you can. The reason we haven't play with it, it's two reasons. One, and I don't know if we're supposed to talk about this officially because this is under NDA from Apple or whatever, but the point is that
let's keep it generic, right?
yeah, from what we have learned, the way an iBeacon works is essentially you put a lot of data in the advertising package. So you don't really never connect to the BLEDuino peripheral itself. You're just reading data that is always available because it's on the advertising package, right? However, the advertising package, in order to be low power, it's really, really small. It's only, I think, 30 bytes, right? And we have all space already used with our own data, like advertising the BLEDuino service, so it knows that it's a BLEDuino, its name, proximity, and everything else that Apple requires, and everything else that we want to have there in order to support
and all
everything
our
that we want.
services that
Right.
we're advertising.
Well, the services are not in the package; they're on somewhere else. But the package only advertises one, which is the BLEDuino service, just to know that it's a BLEDuino. But that takes that's a 128-bit UID, so it takes a lot of space. And essentially, we don't have space to add all the data that you would need to have for an iBeacon. And then the second one is that you can definitely flush it out and change our profile for your own profile, which would essentially have no services, just a new kind of data in the advertising package. But we haven't we haven't documented that yet because Apple hasn't really released yet an official spec on the iBeacon. There's a lot of speculation, and a lot of people have reverse engineer how it works. But knowing Apple, things could change, and we don't want to make a commitment until they are, hey, this is exactly how it's going to work. But it's something that we definitely want to use ourselves, and we want to play with it. So it'll eventually, once it's released and it's official, we will definitely add the instructions and guidelines to how to enable that on the BLEDuino. But an iBeacon, just so you know, it's just a way of using the advertising package. It's nothing proprietary. It's nothing that has to do with Apple. Any BLE peripheral could be an iBeacon essentially. So yes, the BLEDuino could be, and we'll keep you posted on that.
Very good, thank you. Next question: do the Nordic toolchain, all the tools work on Mac?
No.
Oh yeah.
Not at all. I actually had to set up a virtual machine to be able to use the tools. They're just for Windows.
Yeah, and we wish it were for Mac. I mean, if anyone from Nordic is there.
Yeah. It wasn't fun to set up the virtual machine just for that. But I mean, it's free. It's the only tool that works.
Yeah.
So basically, Bluetooth has its set of rules of how profiles should be built, and then every single manufacturer out there with a BLE chip takes those rules and build their own software, because there's no software yet from Bluetooth officially that says, hey, this is how you build a profile for you BLE chip, whether it's from Nordic or TI or whatever. So every manufacturer has ended up building their own software, and because of that, you have limited platforms, and then the profiles are a little bit different, so you have to adapt it, and all those things happen. But I know for a fact that Bluetooth really wants to set up a tool that everyone can use, and then standardize again the process of building the profile. So,
yep. Next question: if the profile on the peripheral or the BLEduino side is changed, and what do we need to change on the iOS side?
Well, it depends how much you change it. The iOS side and the Android side and the sketches and everything else is dependent on that profile, basically. That profile, it's again this set of rules and words and sentences that a BLEDuino can speak to an iPhone, to a central device, and a central device can speak to a BLEDuino. So if you change the profile, you're essentially changing the words that I can speak, the words that I understand. So if you change everything, then you would essentially have to build everything on your own. You could definitely base yourself on our work.
Yeah, I mean, when you change the profile, you're just changing the type of data that both sides are expecting.
Right.
So if you change that, you just have to look at our code and see, okay, this is how they were expecting their data in their service. If I change it in mine, I just have to make sure that um, now I can read the data that I want to add,
Right.
the new type of data. So
Right.
shouldn't be. It's not that you have to rebuild something from scratch, but you have to change a couple things. Yeah.
Yeah, if you change something like I don't know, I want this service to include these other values, then you would just have to like go to that characteristic object that you saw on iOS and add variables for those, and then on the method that we have to sort of like convert from raw data to an actual object, just add a bigger uh, byte array so it has more space to send that data and all that.
Yeah.
But you don't have to change anything else if it's that kind of small change.
Right. If you're worried about not being able to have to send data however you want, I don't think you're gonna have an issue because we have like a bunch of different services for different occasions. And if you want to be really generic, the UART one is just for send raw data. If you want to play with services because that's just what you want to do, because you want to do an end product or something, then yeah, you would have to change it. But it shouldn't be something just from the ground up.
Very good. Next question: do you guys do custom design for those who want to embed this BLEDuino board to their product?
Sorry, doesn't this answer?
So do we do custom designs based on the BLEDuino?
Yes.
Probably not.
No.
Got our hands full of a couple things. We'd love to, but
yeah,
probably not.
Okay. Next question is: can I use BLEDuino as a central device, or can I? Okay.
No.
Now BLEDuino it's a peripheral only.
Okay.
But and that's why we made the BLE Bridge service.
Yeah.
So it would kind of act like a master and just talk to anyone in range.
Right. Yeah, for the BLE shape, it's just peripheral. There are BLE shapes that support both, but the one we're using is just slave, so it can only be a slave and talk
Yeah,
to
in this case,
centrals.
it's a hardware limitation. Yeah.
Yeah. Next question: can your sketch be flushed to other boards?
Yeah, as long as you have some type of hardware similarities there. Yeah, of course.
You will need to have some sort of BLE functionality if you really want it to work.
This question is it possible for iOS to use BLE to discover Bluetooth smart devices, but to send data using the classic Bluetooth?
Yeah, no.
Talking about do mode.
Yeah, exactly.
Yeah. So yeah, no. You would need our devices. It's Bluetooth 4.0, but it's only the BLE side, Bluetooth Low Energy side. It's not a dual mode chip like Vincent was saying that would support both 2.0 and 4.0. That's what the things that the iPhone have, that they can do both. But no, the BLEduino is just BLE 4.0.
Yeah, usually BLE peripherals are just BLE for the sake of the saving energy and all that.
Right. That's the whole point of this new standard, sort of like keep it really, really low power. And then 2.0 doesn't do that.
Correct. Yeah. So what is the maximum bytes you can send over from your BLEduino profile?
So this is a limitation of the. I'm not sure if it's a protocol or the BLE chip that we're using, but it's 20 bytes, and then the way we do UART, for example, right, that you can send us whatever data you want and as many data as you want. It's just that we just split it in chunks of 20 bytes, and then we keep sending until we're done. And we have our own way of knowing when we're getting started, in the middle, and where we're ending.
Yeah, I don't know if you were asking about the bandwidth or the packet size. But yeah, each packet is a maximum of 20 bytes. The bandwidth, we're trying to get it as high as possible, but BLE isn't designed for very high bandwidth in itself. It's made mostly for just kind of passive sporadic transfers of information. But if you want to do kind of a very real-time data, as long as it's not something gigantic like sending music, audio or something, which in BLE's case it would be pushing it.
Yeah.
As long as it's not that, then yeah, you just you'll be fine.
Yeah. For example, the controller, the game controller, every single time that I'm moving the joystick or each button, like it's sending data almost. Well, it was real time, so and it worked just fine because it wasn't that much data.
Okay, so this question is, does your sketch take care of splitting the data?
For that service in particular, it does.
Yeah.
For the EOR service, for any other service, it doesn't because it doesn't need it because all the other services are under 20 bytes. It's like 3 or 4 bytes in average, so it doesn't need to split anything.
Yeah, for the services that do need to split the data, we do handle that. Yes.
Okay. So this question is, first of all, thank you for your great talk. And can you talk about how to debug the connection between the board and device?
It's a good question. This has happened to us a lot of time that we don't know where the problem is, whether it's on the firmware or some cable on the board or just something that I did wrong on iOS. I guess and you're looking at your own chips. When it comes to like debugging hardware, just in general, what I like to do is just make sure that I have a way of debugging on the iOS side that I'm sending the right data, that I can sort of like go step by step and see what I'm actually sending before saying, hey, I'm supposed to be sending this, by the way, can you check if this is what you're actually getting? And then once that's done, Angel sort of like does the same thing that feeds fake data just to make sure that it's actually processing the data how it's supposed to be, and then we sort of like try to do the whole thing.
Right. If you want to do like proper hardware debugging, the SPI for both chips are exposed, so you could just use it like a JTAG debugger if you want to go that route, because it is they're both AVR chips. So if you want to do that, you can just go ahead and do that.
Yeah. And then we have debugged the application while running the hardware as well, like still connected, but I just stop it in the middle and see the data before sending it, and that works just fine. Like there's nothing wrong with that.
Or you could just do classic printing to the serial monitor.
Of course, that works best.
Good old serial monitor.
System printout, all that stuff.
Yes. Very good. I guess that's all the questions we have from our audience today. And thank you, Ramon, and thank you, Angel, for your great talk. And thanks everyone for attending to our webinar. So we'll see you in our next webinar. All right.
No, we appreciate everyone for being here.
Yeah, thank you for the opportunity, Vincent, and thank you everyone for being here and supporting the BLEDuino and supporting us.
All right.
Just so you know, this is being recorded. That's right, Vincent?
That's correct. Yes, it will be published to our website in 24 hours.
Yeah. Good. And feel free to email us with any questions that you guys have. Sorry if we take too long sometimes. We're really busy, but we are always happy to receive questions and people excited about the BLEDuino and stuff like that.
All right. Good job and good luck, guys.
All right. Thanks again.
All right. Bye-bye.